This is the shell sort.
The shell sort is a tweaked insertion sort, which is faster for large groups of data.
To understand the shell sort, you must first understand the insertion sort.
The insertion sort works by taking one element at a time and fitting it into a sorted list. The insertion sort is simple to implement, but not efficient on groups of data larger than 10 elements. The complexity of the sort is order n squared.
We're going to illustrate the insertion sort by using cards. There they go!
The best case scenario for insertion sort is a list that is almost completely sorted and is order n. The average case scenario is a list that is half sorted, half backwards. The average case is order n squared as well.
The worst case scenario is a list that is in reverse order and is order n squared. In this scenario, every element must be compared with all the elements before it is to reach its sorted location. The shell sort works by comparing elements which are separated by a gap of several positions using insertion sort. The gap size becomes incrementally smaller until no gaps exist. Our first gap is 3. So in this case we're comparing 3 to 2, 5 to 6, and 1 to 8, each using insertion sort. Then we put the list back into a single list, and the next time the gap size gets smaller and is now 2. And now we arrange these according to insertion sort. Then we put them back into one list. And this final time the gap size is 1, which means you're comparing what's right next to each element. And we use insertion sort once again. On this last time, the list will be almost completely sorted, as we've seen, and so the insertion sort is more efficient within the shell sort.
The best case scenario for shell sort is a list which is nearly sorted and is order n complexity.
Gap size 3. Gap size 2. Gap size 1.
The increment size chosen also plays a role in the efficiency, and numerous algorithms have been proposed for calculating it. The original proposed by the creator is to divide the number of elements by 2 and use this for the first increment, and then divide this number by 2 repeatedly until 1 is reached.
In the average case, the numbers are half sorted, half backwards.
The worst case scenario is when numbers are sorted, but interleaved 2 to 1, and is order n squared complexity. Even so, shell sort is on average twice as fast as insertion sort.